Hi everyone, my name is Philip. I'm tech lead for Hugging Face and an AWS machine learning hero. I am super excited to talk to you about unlocking the power of generative AI on AWS. Today, in this short webinar, we will cover the brief history of generative AI and deep learning, better understand what generative AI is, and look at some super cool demos, then learn how you can use generative AI with Hugging Face on AWS and take a deep dive on a practical example. Software is eating the world is a famous phrase from Mark Anderson in 2011, who pointed out a disruption on how software is impacting the world by disrupting the traditional business model and transforming industry. During that time, Netflix had its breakthrough with its video offering. Airbnb revolutionized the hospitality industry by basically allowing everyone to offer their homes as hotels. Software was everywhere, powering every device every day. And then 6 years later, within 2017, RNN, LSTM, CNN helped us creating models like ResNet and AlexNet. Back there, NVIDIA CEO Jensen Huang predicted that deep learning will change how we develop software by having an AI-first approach, automating complex chains by using machine learning models. And now, 6 years later, we see that generative AI is eating deep learning. Until 2 years ago, we had like those architectures with CNNs, RNNs, LSTMs. They were all heavily used in the industry, but then there was a shift with the introduction of transformers, which became the default architectures for all deep learning solutions for all modalities. And now with generative AI and the introduction of LLMs, we basically see week by week new LLMs, generative AI models breaking any benchmark for any modality in any machine learning task. And there's really no stopping. We see like weeks over week, new models, new use cases, and better performance. But what is generative AI really? Let's hear what some of the most renovated AI researchers say. Alex Krzyzewski is the creator of AlexNet. He said generative models represent the next phase of artificial intelligence, where machines move beyond simple pattern recognition to create new, unique content. Ian Goodfellow, the creator of GANs, said generative models are key enabler of machine creativity, allowing machines to go beyond what they have seen before and create something new. Jan LeCun is the creator of CNNs. He said that generative models allow machines to learn from data and then create new original content, and they have the potential to revolutionize industries for music, and fashion. Okay, so as a TLDR, we know generative AI generates new data beyond simple pattern in a truly open way. Okay, so what do we know? We know that generative AI are neural networks trained to generate new content for text, image, music. So it's not limited to one modality. We know that they are trained on existing data to learn how to create new data by generating similar patterns and structure. We know that the output generated by the model can be used for various applications, such as generating images, generating text, or even now generating music. We also know that responsibility is crucial, since generative AI models have the potential to create content that can be harmful, toxic, or biased. And we know, of course, that large language models are a subset of generative AI. Okay, so let's take a close look at how LLMs or generative AI has progressed in the field since the release of GPT-3, which was 2020. We can see a visual created by the Survey of Large Language Models, including all of the LLMs released since GPT-3 until the first quarter of 2023. And what we can see definitely is that the pace and the acceleration of how fast large language models were created accelerated by a lot. Now we almost have 6 to 7 models released every quarter, which is crazy to think of. But the downside of it is that not all of those models are open source or even accessible. So, for example, GPT-4 is a closed source LLM, which has limited access through APIs, but there are also models like Gopher from DeepMind, which isn't accessible at all, which makes it hard for research to continue investing in improving the solutions. With all of those advantages we made since GPT-3, it is super essential for us at Hugging Face and personally for me itself as well as that we take a look at the risks of closed source LLMs. So closed source LLMs, as we learned on the slide before, are LLMs which are not really or are only accessible through an API, meaning you might not know what you really do. So it's basically a black box solution. We send our data and we get back a prediction. And like the biggest risk here is the lack of transparency. We don't know if it is one model, if it is multiple models. We don't know which data it was used to train, and we don't know what the provider is doing with our data, if they are using it to further train models, to inspect different model behaviors. We also don't know what happens if a provider makes an update. So we see with regular software development that software needs updates and you need to make improvements, but always with the look at, okay, we need to keep our software backwards compatible. And that's a big issue for models, since how can you secure backwards compatibility when you don't know what a model provider is doing? So you don't have any secureness if your input you are using today in your production application will generate the same output or have the same impact in the future when a model provider makes. However, despite the potential risk of all those associated closed source language model, there's a huge advantage in generative AI. And here you can see on the slide, we only now need 5 Python lines to generate photorealistic images. And the code snippet is using the Hugging Face diffusers library, which makes it super easy to load a model using the from pre-trained method. Then we have our prompt where we define, okay, how should the image look we want to generate, call our pipeline with our prompt, and then save our image. And probably the most famous example next to chat is code. I guess every one of you has either seen, used Copilot or Code Whisperer to improve your productivity, to get code suggestions when working on your application. And since last week, we have an open source alternative with StarCoder, which is a model created by the Big Code organization, which is open source, accessible, meaning you can fine-tune it to your domain-specific data and framework. This enables a lot of new cool use cases where enterprises can deploy code assistant models in-house, fine-tune on in-house framework and in-house best practices for code. We have seen all of those cool demos, but now how can we build generative applications ourselves? And together with AWS, we are working on building solutions to unlock the power of generative AI on AWS. We are making it super easy to use and deploy any of the pre-trained models from the Hugging Face Hub to AWS to train your own models on your own data, or just deploy already pre-trained and fine-tuned models to endpoints to have a secure environment which you can integrate into applications. We are integrating Hugging Face into all layers on AWS. We are offering consultant services as well as our managed solution through the AWS Marketplace. We created together with the Amazon SageMaker team specific deep learning containers and toolkits, which makes it super easy for you to train and deploy generative AI models. And then we are working with the AWS Accelerators team to bring best performance of generative AI models to AWS Inferentia and Trainio. So combining the power of the AWS ML infrastructure and the Hugging Face ecosystem, we basically make AWS the best place to work with generative AI models. Okay, let's dive deep onto our practical example. We look at how you would build a generative AI-powered semantic search for an enterprise. And the key consideration for building an enterprise search powered by generative AI, of course, is security and data compliance. For enterprises, it is super important that data is not leaving their secure environment and they can deploy the whole solution inside their own AWS account. And that's basically what is now possible by using open source generative AI models, where we have an ingestion pipeline, which allows us to generate or create a knowledge database. And then we have an API and an application which allows users to access the knowledge database by asking natural language question through the LLM. And this whole process is called, or architecture is called, retrieval augmented generation. And it is a method that retrieves relevant data from outside the language model and augments the prompt with the context, and then provides the query, the search query, and the retrieved documents to the LLM, which allows us to improve our search results and be able to directly answer questions. So the retrieval augmented generation consists out of like two main components. We have the data store, where all of our data, document, and knowledge is stored. And then we have the query engine with a retrieval model and our LLM. The retrieval model encodes our incoming requests and document into embeddings. And those embeddings are then used to query our data store to find similar documents and embeddings. And those similar documents are then provided into the LLM prompt, which are then used to generate our response and return to the user. Okay, so what are the benefits of like retrieval augmented search? Of course, it improves the search accuracy, since we are combining generative AI with knowledge retrieval to provide more accurate and relevant search results. So I'm pretty sure you use ChatGPT and asked the question, and ChatGPT came up with some wrong answer by just hallucinating facts. With retrieval augmented generation, we are basically avoiding this scenario, since we are providing the model only context, which it can use to answer our questions. So RAG can generate more targeted responses that are tailored to the user's search query. We, of course, enhance productivity and decision making, since users are now able to search on specific questions and can leverage the power of LLMs to get answers quickly and more efficiently. And since it's completely deployed inside your AWS account, we make sure that security and compliance are first principles and use all of the benefits from AWS to be GDPR or HIPAA compliant. Now let's take a closer look on how this really works. So we currently see here the knowledge ingestion pipeline, which is responsible for creating our knowledge database, which we then can use to answer our queries. As a first, we have an API and an S3 bucket, which can be used to ingest documents. So once a user uploads a document to an S3 bucket or sends the document through an API request to our Lambda function, the Lambda function will call our embedding model on SageMaker to create those document embeddings, which are then stored on Amazon OpenSearch. And the cool part here is that we don't need to only create one index, meaning that we could have different indices for different departments, for example. So we could have like a knowledge database for sales and a knowledge database for IT support, for example. Once our data is then stored, we can create our retrieval augmented generation, meaning that we have different clients, mobile or desktop clients, where a user could ask a query. So for example, if we have a knowledge database with all of the AWS documentation, a typical question a developer could ask is, how can I create temporary AWS IAM credentials? Then what happens, the query is encoded by our embedding model, is then retrieved from our OpenSearch database, trying to find the closest documents. And then we create this retrieval augmented prompt, which we feed into our LLM, and the LLM then generates the answer. Since we are using the retrieval augmented process, we are also able to provide the original source from which the answer is coming from. And then the LLM or the Lambda function would return the answer as well as the source. Thank you for listening in. We have a lot more coming, and I'm excited for what you are going to build with generative AI on AWS.